I hope this window is visible to everyone, the live script window. So today it's going to be, we are going to start with speech processing. So you can see here, we are going to start with speech processing. So this first code snippet, what you see, so I am going to record an audio. See, you know that the human speech, frequency of human speech is from 0 to 4 kilohertz. I'm talking about the frequency what you speak, okay, not the frequency what you hear. The frequency what you speak varies from 0 to 4 kilohertz. So the maximum frequency is 4 kilohertz. So sampling frequency by definition has to be 2 times the maximum frequency. So the sampling frequency I've set it as 8,000. Okay. Now I'm going to go for audio. I'm going to invoke the audio recorder function. So if you use the audio recorder function, it can be, you can see the arguments of the function. So first one is sampling rate and how many bits for encoding and what channel you are going to use. That is the audio recorder function. Maybe if you write it separately, we can see what is the arguments of audio recorder function. So it is an inbuilt command in MATLAB. See, sampling frequency, number of bits and channel ID. Number of channels. So I'm going to use single channel and number of bits you can vary. More number of bits you give, the more clarity will be available to your voice. So usually we'll fix it as 8 or 16. Here I'm going to consider 16-bit voice. So I'm initializing a voice recorder object with sampling rate of 8,000 and with a bit of 16. Now I'm going to collect the voice now. See here, I am setting the recording time as 2. 2 means I'm going to record for 2 seconds. Okay, I'm going to record based on the, when I press the enter key, I'll be recording, and after 2 seconds, it will be automatically stopping my recording. I am once again getting my recorded data, and I am plotting and playing my recorded object. This is what is done in the last line. See here, I am storing the recorded data in my recording, and here you see I am plotting my recording, and I am playing the object again. Okay. So it will be very interesting. I am going to record the voice live and show it to you. I hope you can understand this better. Okay. So please listen to the code snippet now. I will be recording a live voice. So see here, I'm clicking on run section. It's saying press enter to start recording. I'll go to command window. See here, I'll press enter and I'll talk a few things. Hello, 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 hello. So this is my voice signal. Hello, 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 hello. And I played it. You can hear the voice was played immediately once the 2 seconds is over. Maybe I'll run this once again. Please listen carefully what is being done. Press enter to start recording. I am pressing enter. My name is Ashok. If you want to see what is your sound waves, what is the equivalent voltage level of your sound, this is going to be the plot. I am plotting this signal. Okay, so this is the equivalent plot of my time versus the audio signal. A simple example, see MATLAB, the audio recorder object is very, very useful in MATLAB. So whatever input device you have, it will get connected to that, and accordingly you can do that. So I have given here just 2 seconds. You can even schedule it for more number of seconds, and you get time versus the recorded data. And I have played the object. So you can hear once I stop recording, once the object is created, it will be playing automatically. So once I speak, after that, the system is going to get back to me by telling what I spoke. Okay, this is the first thing. I think this speech processing is clear. So you can even increase the sampling rate. It will be the signal will become even more clear. It will have a lot of clarity, and even minute sounds can be identified by 2 things. Either you can increase FS or you can increase the number of bits. By doing so, what is the thing you achieve? The sound clarity will be excellent. The clarity of speech signal will be excellent, but what is the drawback? You have to spend more amount of memory to store that sound signal, because when the number of bits is going to be high, naturally memory requirement is also going to be high, and the sampling rate is high. It is going to have more number of samples. More number of samples, more memory. So indirectly, everything is going to target the memory of your device. Okay.